Hi guys, we're here again. Same clothes, same hair, same face. Okay, it's now Friday. Now you might be doing this any other day, but I have to have your homework for today by midnight tonight in order to be considered in class today for Friday. Okay, so you could do it any other day, but as long as I have it by midnight Friday, you're good to go. Okay, so I'm going to share my screen. Today's lesson, Friday, slide 5, we are going to be doing volume of a liquid. I'll have a link here, a YouTube link with this video. You've already clicked it if you got it. Okay. All right, so we're going to do these notes. Now, we did slides 1 through 5 Thursday. And so we are going to start here on slide 6. Let me put that in here. I don't know how many slides are 6 through 9. See, this is so short and sweet. Okay, slide 6 through 9. Okay. So slide 6. So you know how yesterday, was it yesterday? Tuesday, we talked about the most common metric unit for a line was meter, right? The most common metric unit for liquid is liter, right? So we have a milliliter and we have a liter. You can put that in your notes with a little line like we did the other day to explain it. Now, milliliter would measure small amounts of water. Like when you take medicine, you use a milliliter measuring either a spoon or a cup, okay? Or like the syringe that pulls it up. Small amounts of liquid. So you should have your notes titled liquid volume. I'm sorry. Liquid volume. And we have a milliliter is a small amount of liquid. And I'm going to put medicine because that's how you measure your medicine with milliliters. Generally, you guys probably take about 10 mils, maybe a little bit more depending on the medicine and your weight. But liters would be a larger amount of liquid. And can you think of it? Ding, 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 a liter of soda or a 2 liter of soda. Okay, so this is how it looks in your notes. Mind you, this is backwards, I know. You can pause me here if you need to. I'm going to move on. So it's the basic of unit of volume. 1 liter equals 100 or 1,000 milliliters. So you need that in your notes. 1 liter, big L, equals 1,000 milliliters, little l. 1 liter, big L, equals 1,000 milliliters, little m, big L. You can pause me here if you need to. Okay, so when we're reading a graduated cylinder is something that scientists use to measure liquid. Oh, so sorry. So when we're reading a graduated cylinder, it's such a narrow tube that the water bends at the top. You need to read it at eye level. Now, mind you, if we were reading real graduated cylinders, if we were in class right now, we would do something called the Rainbow Lab, and you would have to measure the an actual graduated cylinder with liquid in it, okay? So we call that line the meniscus line. That is the line that you read. So not where the water dips up, but, and I wish I could show you, I guess on Monday or Tuesday, maybe I'll have one full and see if the camera can catch it. But it literally looks like a little bubble is sitting on top of the water. So you would read it under the bubble, okay? Now, for the sake of the assignment that we're going to do today, you're just going to read where you see it. It's pretty easy, so I'll help you. Okay, that's it for notes. Simple, easy, right? Okay, so you're going to go back here, and it looks like we're going to do a guided practice. This looks almost identical to your work for homework. There's only 12 questions, okay? So I'm going to open this with Cami, and I'm going to work through it with you. Okay, so I'm going to put a text box right here for my answer 1. So if we look here at the first one, each big line is like, it looks like a ruler, but standing up. So we have a big line of 10, 20, 30, 40, 50. So it's counting by tens. And it looks like there are 10 tick marks in between each. So we know that every tick mark is worth 1 milliliter. Okay, so I'm going to look here, and we have 1, 2, well, this would be 5, 6, 7. So I know that the water is filled to 7. Do not forget your ml. I do take off half points for forgetting. So not just like a half point for the whole worksheet. Like every single one of those would lose a half point without it. Okay. So then I put it on another text box for number 2. All right, so here, still counting by 10, 20, 30, 40, but are there 10 lines in between? No, there are only 5. So what are they counting by? If it's not ones, it's twos. So each line counts for 2. So here we have 20, 22, 24, 26, 28. 28 milliliters. I know that's a little tricky. So each one is going to have its own rule. You need to look at the rule before you decide how much it is. Okay. Yeah, I must be sleepy. Okay. So this one is counting by 5s. 5, 10, 15, 20 with 5 marks in between. So that means this is 1, 2, 3, 4, 5. So each tick mark stands for 1. So we have 5, 6, 7. We're at 7 milliliters again. Number 4, 10, 20, 30, 40. Okay, so let's just say I can't figure out what the tick mark is. Is it 1? Is it 2? Is it 5? Is it what is it, right? So I'm just going to try. So if I leave from 30 and I count by ones, do I get to 40 by counting the tick marks? So 30, 31, 32, 33, 34. This should be 35 if each tick mark stood for 1. So let's try 2s. 30, 32, 34, 36, 38, 40. It does it. So each one is worth 2. So 32, 34, 36. So this is 36 milliliters. Why? I hit enter. That's why. Okay. So this one, we have 10, 20, 30, 40. There's a lot of tick marks, so I realize in my common sense that each tick mark stands for 1 because it looks like there's 10 in between each 10. But if I wasn't sure, I would start with 1s or 2s or whatever way. So I'm going to start with 1s and see if it gets me to the next big number. So I start at 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Yes. So each tick mark stands for 1. So it's 1, 2, 3, 4 past 40. So we have 44 milliliters. Okay, number 6. It's counting by 5s, 5, 10, 15, 20. So each tick mark looks like there's 5 in between, but I'm going to try anyway. If I started counting 10 and count by ones, will I get to 15? 10, 11, 12, 13, 14, 15. I will. So I have 10, 11, 12 milliliters. All right, number 7. Looks like 10, 20, 30, 40. Looks like counting by ones. 1, 2, 3, 4. 44 milliliters. All right, here we got 10, 20, 30, 40. Are they counting by ones? I'm not sure, but guess what? Lucky enough, it lands right on the big number. So I know this is 40 milliliters. Okay. So 4 different objects were placed in a graduated cylinder at one time. This is called displaced volume. So everything has volume. This button, this battery, this nail, and this key all have volume. What is their volume? Well, you can't really find the volume of a key. It's not a regular shaped object. We can't do what we do with what we did yesterday with volume of a solid. You can't measure length times width times height because it's not a cube. It's not a box, right? It doesn't have 3-dimensional sides really, or we don't have the tools to do so. So you can do displaced volume. Okay, so we have an empty graduated cylinder right here on the left. This empty graduated cylinder has 10 milliliters of water in it. When we place the button in the water, we know that that button has weight, right? So it pushes the water up. So how much displaced volume did the button add to the water? Well, it was at 10, now it's at 12, right? So it displaced the water by 2 milliliters. What about the battery? When the battery was placed in, it went from 10 to 15. So there's 5 milliliters of displaced water. I'm going to have to pause. I don't know how to do that. Pause. Okay, that wasn't so bad. Okay, back to screen share. Okay, so when we put the nail in, the water went from 10 milliliters to 11 milliliters. So there was 1 milliliter of displaced volume. When we put the key on, it went up 1, 2, 3 milliliters and went up to 13 milliliters. So there's 3 milliliters of displaced volume. So that's how much the water rose when we put that object in. Okay, the question says, number 9, which object had the greatest volume? So did the button have the greatest volume, the battery, the nail, or the key? So basically, which one made the water raise the most? Think about it. The battery, ding, ding, ding. So number 9 is battery. Whoop. Okay. Number 10, which object had the least volume? So when you put the object in, which one rose the water the least amount? Correct, the nail. Okay, that is it for practice. If you need to rewatch, if you need to come back and rewatch while you do the assignment, please do. Let me show you where the assignment is. It is assignment 006. So we're going to go to class, Google Classroom, go right here to weekly assignments, 006. It will be dark on Friday morning, so you'll be able to do it on Friday morning. Click on it, and look, a Google form that is, once again, multiple choice. So easy. Could I be any nicer? Okay, don't forget to put your first and last name. That is very important, so I know whose it is. Number 1, you look here. So 20, it can't all be ones. 21, 22, 23, 24, 25. That doesn't work, so it's counting by 2s. So look, though, this is trick. It's between the 2s. So 22, 24, 26. What number falls between 24 and 26? I will not tell you, but I hope you get it. Okay. Do that. There are a couple bonus questions at the end. How much water was displaced when the button was dropped in? Meaning, how much did it go up? So if it was at 10 and it went up 1, it went to 11, it went up 1 milliliter. I don't know if that's true because I haven't looked at the question. Okay? All right. They're not bonus questions. You have to answer them, but they were not on the worksheet. They're extra questions. Okay, if you have questions, please email me. Check to see if I'm on Zoom. I might be able to get on Zoom during your class period. If not, and you need to set up a Zoom, I will do my best to do that for you. Other than that, have a great long weekend. Enjoy that extra day, and I will see you on Tuesday. Bye.